Hello everyone, this is Sir Aris. Today, let us have a review on the topic of vectors. The notation that we'll use is that we indicate the vector by a bold-faced letter, for example, this A here. The component of a vector is indicated by a subscript, so EX for the X component of A. But when you're writing, it would be difficult to write in bold-face, so to handwrite vectors, you just write the letter but put an arrow on top. The magnitude is the length of the arrow representing a vector A. It's called the length or the magnitude of A. It's written as absolute value of A or simply A. Uh, when you write, it would be without the arrow. By Pythagorean theorem, the magnitude is given by ax squared plus ay squared in two dimensions, or ax squared plus ay squared plus az squared in three dimensions. So consider this example. You have a force F um, in the figure. So the figure would look like this. Suppose this is the X and Y components. This is F. Okay. This is 4 pounds here in this direction. This is um, 3 pounds. Okay. So find fx, fy, f, and theta. Fx is simply 4 pounds. Fy is 3 pounds. So F magnitude is just 4 pounds squared plus 3 pounds squared. Take the square root. 4 squared is 16. 3 squared is 9. 16 plus 9, 25. Square root. Take the square root of 25. That's 5. Okay. The angle theta can be determined from taking tangent theta. Tangent theta is 3 pounds over 4 pounds. So this opposite over adjacent. Then that would be 3 over 4, which means that theta is arc tangent of 3 over 4. Okay. So to add vectors, we can use one way is to use parallelogram law. To find a plus b, place the tail of b at the head of a and draw the vector from tail of a to the head of b. Suppose this is a, this is suppose this is b. Okay, we place the tail of b at the head of a, so we can translate this. Make sure that you translate it in a way that the new position of this is still parallel, but with tail at the head of a. So this is, we can translate b here. They have the same length, the same direction. Here doesn't look quite the same, so approximately the same, like this. So that's our new b. So this is the same as b, but with tail placed on the head of a. So we draw a vector from the tail of a to the head of b, and this is now our a plus b. We can also add using components. Say a plus b has components ax plus bx and ay plus by. Properties of vector addition, they are commutative. Associate, uh, Associative law is followed. If you multiply c uh, with a, actually this is not, this is generally a property of vector. So it's c times as long as a. The negative of a vector is defined as a vector of same magnitude but in the opposite direction. So a minus b means that a, we are adding a and minus b. Zero vector is a vector of zero magnitude, and a vector of magnitude 1 is called a unit vector. So for example, a divided by its magnitude, the answer is 1. Uh, or it would be the unit vector, so the magnitude would be 1. In terms of components, we can make use of unit vectors I hat, j hat, and k hat corresponding to unit vectors along x, y, and z directions. If ax, ay, and z are scalar components of a vector x, y, z axis, um, components along x, y, and z axis, then the vector A can be written like this. If A and B are in three dimensions, then if we add, we simply add, um, let's say this is A, this is B, we can simply add the components of A, B, AX, BX, AY, BY, AC, BZ. The two kinds of uh, products of vectors are scalar product, which gives a scalar answer. Um, it's also called dot product or inner product, and also the other one is vector product or sometimes called cross product. It gives us the answer is a vector, so it would need direction. For the scalar product, the definition is this: you have a dot b equals a magnitude times b magnitude times cosine theta, where theta is the angle between the two. We can think of a dot b as a cross projection of a on b. So suppose this is a and this is b, okay, and the angle is theta. Um, b cosine theta, you can think of this as, suppose this, let's extend this one. If this is a right triangle here, then um, b being the hypotenuse, or yeah, the hypotenuse, we can project it towards the direction of a, that is equivalent to b cosine theta. So b cosine theta times a. Or you can also think of b as, we project a towards b. So let's say we write a right triangle that looks like this. So a being the hypotenuse, project towards b. This length would be our a cosine theta. Okay, so a cosine theta times b, that's similar to this statement. Scalar product is commutative, so you have a dot b that's equal to b dot a. Also, the distributive law is obeyed, so b plus c dot a equals b dot a plus c dot a. For the unit vectors, let's say I dot I is magnitude of I times magnitude of I times the angle between two is 0, so that's cosine 0 is 1. 1 times 1 times 1, that's 1. The same thing for j hat, that j hat, and k hat, that k hat. But for uh, the the scalar product of two different unit vectors, if the angle between them is 90, the answer is 0. So j dot k is 0, k dot I is 0. Therefore, if we write a dot b in terms of components, you can distribute the terms, say axi times dot bxi, that's axbx here, but axi dot byj, that's 0, axi dot bzk, that's also 0. So we only have these three surviving terms. Example, find the angle between vectors a and b. So if you use the formula of the dot product, take note that a dot b equals a b cosine of theta. So if we know a dot b and b, we can get cosine theta and also theta. A dot b from our dot product in terms of components, we can use the components of this. So 3 times negative 2 plus 6 times 3 plus 9 times 1. So that would be minus 6 plus 18 plus 9. The answer is 21. For the magnitude of A, that would be 3 squared plus 6 squared plus 9 squared. square root, you can factor out the 3 squared. So 3 squared of 1 plus 2 squared plus 3 squared. 3 squared is 9. 9 plus 4 is 13. So this is 3 squared of 14. For b, you have 2 squared plus 3 squared plus 1. This has a negative, but doesn't matter. We are squaring that one. So you have 4 plus 9 plus 1. That's square root of 14. So from our formula, using this, so a dot b is 21. A is 314. B is square root of 14 cosine theta. So you have 21 divided by 14 times square root of 14 times square root of 14. That's 14. So we have 3 times 14. 21 is 7 times 3. 3 cancels out here. 14 is 2 times 7. So this becomes 1 half. And the theta that gives cosine theta equals 1 half is 60 degrees. If two vectors are perpendicular, then cosine theta is 0. So the dot product is 0. If two vectors are parallel, the components are proportional, so you can write like this, the components. Now let's consider the other type of vector product, the cross product of, or the vector product, or called cross product of A and B is written as A cross B. The magnitude is given by A um, cross or A times magnitude of B. This is supposed to be B. So A B sine of theta. Theta is the positive angle, is the smallest angle between A and B. Now that's only the magnitude. The direction we also have to specify is perpendicular to both A and B. The direction, suppose this is your the direction of your A, and suppose this is the direction of your B. Now if this is a plane, think of a plane perpendicular to both of them. That's your direction of A cross B. Now to determine the direction, let's say if we reorient this, just use the right hand rule. If you have a screw, you just go around where it advances. So let's say you start from A, you turn towards B, it would advance towards A cross B. Or using your right hand, you point your right hand towards A, you curl it towards the direction of the second vector B. Wherever your thumb is directed, that's the direction of A cross B. Now if you start from B, cross it towards A, the direction of your thumb would be downward. So A cross B is equal to negative B cross A. The cross product of any two parallel or antiparallel vectors has magnitude 0. So for example, A cross A equals 0. Or A cross negative A, that's also 0. For unit vectors, I cross I, or J cross J, or K cross K are 0. But if they are different, I cross J, for example, the angle between them is 90. So sine 90 is 1. The magnitudes are 1. So the answer is 1. The same thing with J cross K and K cross I. These are magnitudes. So even if we interchange them, the magnitude would still be the same. However, the directions would be different. Let's say I cross J would be K. J cross I would be negative K. J cross K is I. K cross J is minus I. K cross I is J. I cross J is minus I. Now, if you forget the sequence, you can always write in a counterclockwise directed circle where if you traverse counterclockwise, the direction is positive. So you start with I, J, and then K. That is, if you take the cross product of I cross J, the answer is positive K. But if you start from J towards I, it goes opposite the direction of the counterclockwise direction. So the answer is negative of k. Okay, so again, if you go counterclockwise, positive, clockwise, negative. And counterclockwise is the direction of the sequence I, J, K. Okay. Um, the vector product follows the distributive law, so that in component form we can also distribute this uh, unit vectors with components here to these components. Okay, so if you write A cross B would be, so AXI cross BXI, that's 0, but AXI cross BYJ, that would be AX BYK. AXI cross BZK, that's negative AX BZJ. AYJ cross BX, that's negative AY BXK. AYJ BYJ 0. AYJ BZK, that's positive AY BZI. Okay, plus you have AZK BXI, that would be AZ BXJ. AZK BY, that would be negative AZ BY, so J or KJ, that's I. Okay, AZK BZK, that's 0. Okay, so here you can group terms that contains the same, let's say I. You have here AY BZ minus AZ BY, plus group terms with J. So you have here AZ BX minus AX BZ J, plus terms with K. You have AX BY minus AY BX K. This can also be written in a more compact form by making use of the determinant. So I, J, K on the first row, A, X, A, Y, A, Z on the second row, B, X, B, Y, B, Z on the third row, the sequence. Um, Although it's not important, but for you to easily remember, you have I, J, K, A, X, A, Y, A, Z here, and B, X, B, Y, B, Z. Okay, that's our compact form for A cross B. Find a vector perpendicular to both A and B. We know that A cross B is perpendicular to both A and B, so basically we're only looking for A cross B. Using the determinant form, you have IJK, so 2, 1, minus 1. Here, 1, 3, minus 2. Okay, so this is simply multiply, so use the first row. You have I with um, cofactor minus 1 to the power of 1 plus 1, so that's positive, times the determinant of, so you cross this, so you have 1 times minus 2 minus 3 times minus 1. Okay, now for J, you have negative 1 to the power of 1 plus 2, that's 3, so minus J. And then you have 2 times minus 2 minus negative 1 and 1. Okay, plus K times negative 1 to the power of, here 1 plus 3, that's 4, so you have positive K. 2 times 3 minus 1 times 1. Okay, you have I minus 2 minus negative 3, so this is 3 minus 2, that's 1 I, Okay, here you have negative 4, um, negative 4 plus 1, so that's negative 3 times negative, so that's positive 3j. And then here you have 6 minus 1, that's 5, 5k.